1.9 today. Factor strings, prime factorizations, and exponents. There's a lot of material we're going to cover out of this today. You may be watching this video a couple times because there is, like I said, a lot of content today, and it may be a little confusing. So I'm going to break it down as slowly as I can and talk about every little piece, and hopefully we'll go through this. Now, we've already talked about exponents a couple chapters ago when we were talking about squaring numbers. Remember how we talked about 5 times 5 equals 25, and I told you that could also mean 5 to the second power, and I said that is not 5 times 2. That does not work. It's 5 times 5, and that gets you 25. So exponents, not going to cover that much today, but the other ones we will. Okay, factor strings. If you think of a number, for example 24, there's a lot of different ways to name that number. And what I mean by name that number is you can come up with a bunch of combinations of operations and digits that equal 24. Here are a few. 20 plus 4, 21 plus 3, 48 divided by 2, and so on and so forth, okay? So you can see all of these different combinations of numbers that you can rename 24 as. But what we're going to focus on today is we are going to focus on this idea of factor strings. And all factor strings are, they're a way to rename this number, but there's a rule now. You are only allowed to multiply. You cannot use addition or subtraction or division or anything like that. You're only allowed to multiply here. So you should be able to come up with some factor strings for this. Some that are kind of obvious, or at least should be if you know your math facts. 4 times 6, 2 times 12, maybe even 3 times 8. But if you think a little deeper, you can come up with some more complex factor strings. The only rule is you only have to multiply. You're only allowed to multiply here. So what if I did 2 times 2 times 6? Or what if I did 3 times 2 times 4? 2 times 2 is 4, times 6 is 24. 3 times 2 is 6, times 4 is 24. And what if I went even further with this, and I broke it down even more, and I went 2 times 2 times 2 times 3. 2 times 2 is 4, times 2 is 8, times 3 is 24. What you'll notice is I've got 3 sets of factor strings here. These factor strings are 2 factors long. These factor strings are 3 factors long. 1, 2, 3. And this factor string is 4 factors long. 1, 2, 3, 4. So you can have these factor strings go longer than 2, into 3, into 4, possibly even more than that. A factor string is really just a list of factors. That's a definition right there. In case you were wondering what a factor string means, it's just a list of factors. Now there is a little rule though. The number 1 is not allowed as a factor, otherwise you could go on forever. 24 times 1 times 1 times 1 times 1 times 1 and so on, that still equals 24, and I could keep writing times 1 forever. So 1 is not allowed in factor strings. We don't do it. Okay? Here are some factor strings for 16. 4 times 4, 2 times 8, 4 times 2 times 2, and 2 times 2 times 2 times 2. All of these are factor strings for 8 or 16. That's what they all equal. Now here's the cool thing about factor strings. In order to figure out some factor strings, you don't have to take the same route as the person sitting next to you. And that's one of the nice things here. I don't care what path you take to get to the answer, as long as you get to the right answer. Because you may see 28, and you may realize that 28 is, let's say, 2 times 14. But the person sitting next to you may not know 2 times 14, and they look at 28 and they see that it's 4 times 7. These 2 factor strings are both valid. They work. But you can break these down even further. Now, we have a problem. 2 is a prime number. The only way to break 2 down is to do 1 times 2. But, like we said, our rule, 1 is not allowed. So we have to stop that little branch right there. We have to stop at 2. We can't go any further. 14 is not a prime number. We can break it down into 2 times 7. Now, 2 is a prime number. We learned that up here. 7 is a prime number. So what we're going to do is we're going to pull these 3 numbers down and we're going to make a factor string. 2 times 2 times 7. Now look at this one over here. 4 is not a prime number. We can break that into 2 times 2. Well, we know 2 is a prime number. We know 2 is a prime number. And we know 7's a prime number. So what we're going to do is we're going to pull these 3 down. And we're going to have 2 times 2 times 7, which is exactly the same thing over here. But we both started in different places, and that's fine as long as you get to the end result. Now, what's really interesting about this is you see how that all 3 numbers in this factor string are prime. All 3, 2 and 7 are prime numbers. That, by definition, is our prime factorization. Now the prime factorization definition here. It's a factor string that's made up of all prime numbers. That one would be the prime factorization. It's also the longest factor string. Take a look at 12. Let's break it into 2 numbers. Now whether you pick 4 and 3 or 2 and 6, it doesn't matter. Let's go with 4 times 3. Well, 3 is a prime number, so we stop. 4 is not a prime number, so we're going to do 2 times 2. We're going to bring our digits down. 2 times 2 times 3. And that right there, since all 3 are prime numbers, that is our prime factorization for 12.